Hello, we are in Chapter 5, Section 5.6, Rationalizing Denominators. In this video, we are going to go over problem number 4, where we will rationalize more binomial denominators, assuming that all variables represent positive numbers. So in part A, we have the sum of two expressions with square roots involved, so we multiply by the conjugate of the denominator, which in this case is the square root of x minus 2 times the square root of y. Of course, we multiply the same thing into the numerator as well. And now starting with that denominator, we get the difference of squares, so the square of the square root of x is just x, and the square of 2 times the square root of y will be 4 times y, because the square of 2 is 4, and the square of the square root of y is y. In the numerator, I'm going to distribute that 5 square root of x, acknowledging that square root of x multiplied by the square root of x is just x, and then we have minus 2 times 5 is 10, and the square root of x multiplied by the square root of y is simply the square root of xy according to the product rule for radicals. Now there is nothing to simplify here. Don't even think about trying to simplify like the 10 and the 4 or something like that. This is it. And then in part B, the conjugate of the denominator is 3 plus the square root of 5. So we multiply it into both the denominator and the numerator. Again, starting with that denominator, the square of 3 is 9. The square of the square root of 5 is 5, so we get 9 minus 5. And multiplying out things in the numerator, foiling in other words, we get 3 times the square root of 5, then plus the square root of 5 squared, which is just 5, minus 2 times 3, which is 6, and minus 2 times the square root of 5. Then in the denominator, we simply get 4, while in the numerator we can combine the numbers together and combine the like terms with the common factor of the square root of 5. Now 3 minus 2 is 1, so we get 1 square root of 5, which is simply the square root of 5, and then 5 minus 6 is negative 1, so it will be minus 1, and that's gonna be it here.